Okay, let's try to solve the next example, which is example 1b. Okay, show that 2 cos squared x minus 1 is equal to cos 2x. So meaning that we want to prove that the left hand side is equal to the right hand side. Okay, so from here we can start with left hand side, or we can start with right hand side. Okay, so for example, in this case, I think I want to start with right hand side. Left hand side. Okay, so now we need to use the definition. Still, we have the same question here. By using definition, we need to prove the B. Okay, so 2 cos squared x minus 1. Okay, so we know that the cos squared x, okay, so cos x is basically ex plus e minus x over 2. So since it's squared, so again, okay, minus 1. Okay, so for this case, we can cancel out that one, so we can take out the half. Okay, so ex with ex is e to x. Okay, and then ex with e minus x is e0. Okay, so e0. Okay, plus, okay, we have another one here. Ex with the ex is e0, because minus x plus x 0, right? Okay, and then last one, e minus x with e minus x, which is e to x minus 2x minus 1. Okay, so we need to simplify. So we will obtain, so basically e0 is 1, e0 is 1. Okay, so we'll have e to x plus e minus 2x plus 2 minus 1. Okay, so we just multiply e to x plus e minus 2x, so basically over 2 plus 2 over 2 minus 1, so e to x plus e minus 2x over 2. So yang ni 1 minus 1 0 lah. Okay, therefore this one is basically is equal to cos 2x. Okay, so why we say that? Because we know that cos x is equal to ex plus e minus x over 2. When we have 2x, so meaning that we need to substitute all x with 2x lah. So here is 2x, so here is 2x also. Okay, so 2x. Okay, therefore this is cos 2x. Okay, alright. Okay, that one is for 1b. Okay, so now let's move to number 2. Okay, number 2 is we want by using identities. Okay, so this time we want to solve by using identities of hyperbolic function. So we have a lot of identities in the previous video. Okay, so we can choose any of the identities to prove the left hand side here is equal to the right hand side here. Okay, so let's try this one. Okay, so number 2, so we have 1 minus tangent squared x over 1 plus tangent squared x equal to secant 2x. Okay, so let's say I start with the left hand side. 1 minus tangent squared x over 1 plus tangent squared x. Okay, so let's say I want to change the tangent. Tangent h, we know that the one is sine over cos, right? So 1 minus sine squared x cos squared x. Why I change this? Because that is the only identities that I know from here. Okay, so 1 plus sine squared x over cos squared x. Okay, So I think I want to change the denominator. Okay, we multiply. So we have cos squared x minus sin squared x over cos squared x. Okay, so yang atas ni. And how about the denominator? Saya samakan juga denominator dia. So we will have cos sin squared x over cos squared x. Okay. So now from here we can simplify. Okay, sebabkan dia bahagi, so yang bawah denominator when we want to multiply will be opposite lah. Okay, so it will be cos squared x minus sin squared x over cos squared x ni bila kita multiply, yang denominator bila naikkan ke atas dia akan opposite. Okay, so we'll have cos squared x minus sin squared x. Okay, so now we can simplify. So this one we can cancel out. Okay, oh yang ni plus Okay, plus ya. Sorry. Okay, we have plus. Okay, so now we will have cos squared x minus sin squared x over cos squared x plus sin squared x. Okay, alright. So basically, cos squared x minus sin squared x is equal to 1 from the identity, and cos squared x plus sin squared is basically is a cos 2x. Okay, therefore from here 1 over cos is basically is a secant 2x. So it's proof lah. Okay, alright. So that one is for number 2. Okay, let's try question number 3. Solve the following x, giving your answer in 4 decimal places. So meaning that in this case we need to find the value of x. Okay, so it's different lah. So untuk question 1b tadi, we need to show but using the definition, is proving. For for number 2 also we need to prove, using identity. But this time we don't have to prove, but we want to find the value of x. So we have different type of question here. Okay, so let's try. We want to solve for x. Okay, number 3. We have cos 2x equal to sin x plus 1 just now. Okay, so now we want to find the value of x. Okay, so for this case, since we have cos, we have sin. Okay, so normally we need to change to one function only lah. So for example, let's say we change to sin. Okay, so we know that cos 2x is basically is 1 plus 2 sin squared x equal to sin x plus 1. So basically we need to use the identities. Okay, so cos is equal to this one. Okay, so now since we look at this one, so we just bring sin to one side, sin squared x minus sin x. Okay, so 1 minus 1, so it will be 0 lah. So here we can simplify sin x. So we have 2 sin, right? So that one's quite sin x minus 1 lah. Okay, because kita dah fakturkan. So in this case, we have two values, sin x equal to 0 and 2 sin x minus 1 equal to 0. Because this one is polynomial. Polynomial maksudnya kuasa 2 lah. Bila kuasa 2, kita akan ada dua value. Okay, so you just use a calculator. So this one is sin inverse 0. We will obtain 0. Just use a calculator. So this one we need to rearrange. So dapat 1 sin x 1/2. So x is basically sin inverse 1/2. So you just use a calculator. Sin inverse. So you tekan height, shift sign, you akan dapat sin inverse. So you tekan 0.5 lah. So you akan dapat 0.4812 for decimal places. Okay, in order to find this one, the sin ni, just use your calculator. You tekan HYP. Okay, and then you tekan shift, and then you tekan sign. Okay, so you will obtain sin inverse. Okay, half. Alright. So you have this value, two value, x equal to 0 and x equal to 0.4812. Okay, this is okay. So you can do it by yourself. Number 4, number 5 and number 6. Okay, so number 4, solve for x. Okay, so this one is solve for x. Okay, same as number 3. Okay, number 5, by using definition of the hyperbolic function. So meaning that one is same as 1b. Okay, so this one is equivalent to number 3. This one is equivalent to question 1b. This one solve. Okay, so this one also same as equivalent as